our Design 3 project, the Environmental Control Unit. Our client is NDIPAD advisors Scott Smith, Sami Khan, and I'm Jeremy Reller.
I'm Peng Gao.
I'm Edie Zhou.
I'm Tyler Keller.
And we're just gonna go through it a little bit. We started out with a device from NDIPAD called the Voice IR. Basically what it did is it helped people with disabilities or limited mobility control IR devices with their voice. So you put your IR code in from a remote, and then you would put your voice in, and it would recognize the voice and sync it with the IR code, and you'd be able to control your, whatever device you wanted to. We wanted universal remote-like capabilities that would recognize your voice, and it'd just be easy to use, easy to add codes for the user, so almost anybody can use it.
So we have a Arduino microcontroller. It has 2 inputs and 2 outputs. Here is the original infrared signal. It goes into the infrared sensor and stores the infrared command into the Arduino microcontroller. And this is the speak up voice recognition. It's used for storing your voice command. After your voice is matched up with the infrared command, it will send out the IR signals through the infrared emitter and control your infrared device. The LCD will help you users with instructions and stuff.
For the software side, we have a original signal coming in, and we can catch the rising edge and dropping edge. So therefore, we can get the perfect timing of the high pulse and low pulse, and then we can store them in the flash memory and also we can count how many pulses it has, and also store that in the flash memory. And when people say something, and then the speak up voice recognition can send out whatever pulses you preset it is to Arduino, and Arduino can pull out the pre-stored signal from the flash memory, and then it can generate a PMW, which is at 38 kHz, and then send to the device you want to control. And therefore, that's the way you can control the infrared device.
So here we have a schematic of our PCB layout that we had to make for the rest of our project. We have power coming in, controlling the IR receiver, and then we have that signal coming out, and that will go into the Arduino. And here we have sockets for our buttons, one for up, down, learn, and then mode. And that all ties into ground. And then up here we have 5 volts coming in, and we have a resistor, and then we have our IR LED that will send out the IR code to control your device. And here we have a transistor and our Arduino signal right here. I'll go through the resistor. Our resistor values are anything less than 4K for RB and about 22 ohms for RA, just to get our transistor to saturate. Here is the a speak up, which is the voice recognition part of our project, and then that takes a signal and goes into the Arduino, which ties into the infrared code. And here's the PCB light or PCB board that ties into the buttons up here.
So this is our product look like. We have 4 buttons used to control the LCD screen. One is up and one is down. These 2 are used for selecting the commands. And this is learn. After you select the command, you can press learn to store in the IR signal. And this is mode switch. It switches from learning mode and listening mode.
So in the beginning of our design to our first semester, we sort of realized that voice recognition, doing it, getting our own chip, doing it on our own, was not really plausible given only 2 semesters to do it. So we just kind of decided to go with another device that would do the voice recognition for us, and then we'd figure out what to do with whatever that device outputted into the Arduino. We figure out how to do it in the Arduino.
So at the first semester, we had issues with the infrared control. We can successfully store in the IR signal, but when I output it, the IR signal is off. And we switched to a new library, which worked pretty well from then.
So originally, we purchased an Arduino Uno and an EasyVR. We ended up switching both of them out because the Arduino Uno was too slow at processing, and it also didn't have enough memory. The EasyVR only held a maximum of 15 voice commands, and we needed more than that.
At first we used Uno, we didn't have enough memory, and then we switched to Arduino Duo, which has more memory, and then we realized that it doesn't have any EEPROM. And originally, when we were trying to store more than 3 codes, the processing gets really slow, and then we try to store them to flash memory, and also it is non-volatile. That means even you unplug and plug it in, the signal is still stored in the board.
On demo day, we had a bit of a disaster with our project. It wasn't working correctly with the TV, but it was working good with the VCR, so we were able to demonstrate that during demo day. And then after demo day, we re-uploaded the code, and then it worked from then on.
This is our budget. We had a speak up, IR sensor, and super bright LED, which is infrared, Arduino Duo enclosure, and PCB board. Enclosure and PCB board are made in our department, so it didn't cost any money, and the LCD screen. So totally we had $89.5 for budget.
So ultimately, we're pretty happy with our final product, and pretty excited to give it to NDIPAD, just because the Voice IR, the original device that we were basically replicating, is going off the market, and for starters, it was just way too expensive for normal people or even disabled people to use or have, and we made something a tenth of the price of that works just as well. And we learned a lot. We had a lot of issues, but I think overall we're very excited to give this NDIPAD.